everybody, my name is Boros. I'm a principal architect at Percona, and today I will talk about choices for OpenStack HA. Of course, because we are Percona, we will focusing on choices on the database backend's high availability, if the database is MySQL. So Percona is the oldest independent third-party MySQL consulting and support organization. We have different parts of the company like consulting, support, we have a remote DBA part, we also offer training. We have a global 24/7 staff, and all of Percona software is open source, and they are made based on our experience on the field. So if we encounter some error or some scalability bottleneck which affects a lot of people, that goes into our products. And many use cases, there are many use cases for MySQL, for OpenStack, including using it as a core database for OpenStack. For example, using it as a backend of Nova or something like that. Let me talk about a bit about that product, about our products. Percona Server is our enhanced version of MySQL Community Edition. Percona Extra Backup is our InnoDB non-blocking backup. Percona ExtraDB Cluster is the latest Percona Server, the latest extra backup, which is used for state transfers, and the latest Galera. And they are integrated in a way that it's fairly easy to administrate. And Percona Toolkit for MySQL is a set of command line tools that makes your life with MySQL a lot easier. So if we see an issue, for example, we saw that it's often an issue that you have to compare what is on the master and the slave, so we made PT table checksum and we made it available for everybody. Okay, so if we are talking about high availability and MySQL, probably everybody knows about replication. And by that I mean MySQL's built-in replication. That's quite an old feature. It's there from 3.23, and replication is asynchronous, and data can be different on the master and on the slaves. It can be different from various reasons. It can be different because the data is not yet replicated. It can be different because somebody wrote a slave, even if it's possible even if the slave is read-only with a super user. So because data can be different, we have the PT table checksum tool to verify integrity. If the data is different, we can fix replication with PT table sync. And the new PT table checksum in Percona Toolkit 2.x uses resources in a lot smarter way than the previous versions. But Percona Toolkit 2 is quite old already, so probably if you are using Percona Toolkit, you are using Toolkit 2. So some other options when it comes to high availability options. You can of course make MySQL highly available like you would make anything highly available. Put the data files on a shared storage and use your favorite clustering framework to failover, like stop the database, mount the storage on the other side, start the database, and it will be highly available. Or you can use Pacemaker and DRBD for that. So DRBD is a distributed replicated block device. It's synchronous replication at the block storage level. Many people are using a master-master setup, which means that you use two servers. Server 2 is the slave of server 1, and server 1 is the slave of server 2 with manual failover. This is typically used at the beginning. It can be used by hand or by some type of replication manager. There are replication managers. MMM is the old one, which is not actively developed anymore. And there is MHA and the Percona Replication Manager. So they are layers on top of regular replication to provide a band-aid for that. And there is Percona ExtraDB Cluster. So Replication Manager is practically an automation layer on top of regular replication. It can automate a whip switch if there is a thing as a whip. In many replication managers, it's not even compulsory. It can automatically choose the slave to promote, and this is a harder task than it seems because the slaves are asynchronous and they can be at different points in time. And they can automate repositioning of the other slave after slave promotions. But replication managers are based on replication, so all the drawbacks of replication still apply, like they are single-threaded, they can be consistent, it can go inconsistent, and the fact that it's asynchronous. Here is an example topology for replication manager. So we have one master and many slaves. If a slave fails, it's fine because we have more of them. If the master fails, then the replication manager will choose a slave to promote, and it will choose the slave which is the most advanced in time, which has the most data from the master. If you are using semi-sync together with this, you can know that the slave which is the furthest in time has actually all the transactions, because semi-sync replication guarantees that a committed transaction is already in at least one slave's relay log. Okay. Let me talk about Percona ExtraDB cluster, which is something completely different. In ExtraDB cluster, any node is writable. Your application server typically connects to some kind of load balancer to decide what node to connect to, but this is not necessarily needed. For example, if you are using JDBC, the JDBC driver has load balancing capabilities built right in, so your JDBC driver can just connect to all three nodes by some policy. Each node sends the writes to each other node in parallel. And on this drawing, the bidirectional arrows represent group communication. So a group communication is established between all of the cluster nodes at startup. And let's talk a bit about how replication works in ExtraDB cluster, because that's kind of the key point to understand its limitations, or how is it different from regular MySQL, and what of the corner cases you have to be aware of. So let's say we issue a write transaction on the node at the top. Reads are always local, so reads don't involve network traffic at all. We read locally. This is on top of InnoDB. We issue the transaction on node 1, and upon commit, it will send the transaction to all the other nodes in parallel. Replication happens in write sets. A write set is practically a row-based MySQL log event plus some metadata. The plus some metadata is good for two things. First is that you can take a look at two write sets and tell if they are conflicting or not. And you can take a look at the write set and the database and tell if the write set is applicable to the database. So the originating node for the transaction, let's call this master, but the master can actually change from transaction to transaction. The originating node will send it to each other node where they are doing the certification process. And the certification process is compare the new write set to all write sets in the queue to check if they are conflicting or not. If they are conflicting, then the write set will be rejected and I won't have a successful commit. Next, it checks if it's applicable to the database. And if it's applicable to the database and doesn't conflict with anything, then it puts it to the queue. And at this point, I will have a successful commit. So writing on the remote database node is not part of the synchronicity. But this way, because the queue is persistent, it's guaranteed that I won't lose a committed transaction, because by the time of commit, I already have it at 3 nodes. Also, one of the great features in ExtraDB cluster is parallel replication, and parallel replication can happen because of this mechanism. Because we have a queue with more write sets, and we do know that the write sets are not conflicting, right? Because we checked it at certification time. If they are not conflicting, then we can apply them in parallel. Percona ExtraDB cluster also has multi-data center capabilities. Multi-data center capabilities are much better in ExtraDB cluster 5.6. So I have two architecture diagrams here. On the left-hand side, what you see is 9 nodes in 3 data centers. The magic number in ExtraDB cluster is always odd, because if you have 2 machines and you want high availability with automatic failover, you can have the split brain scenario, which means that if you cut the network link in between them, node 1 will think it's alone, node 2 will think it's alone, and they both start to provide the services. If this is a database, then it's more of an issue than otherwise, because you are start serving diverging data, and you will start having diverging data in the two nodes. So we need at least 3, and we need, and the majority of the nodes should be able to see each other in group communication for the cluster to be up. So with 3 nodes, we can have 1 node failed. With 5, we can have 2, etc., etc. And similarly for data centers, if we only have 2 data centers with the same number of nodes, then we can similarly have a split brain scenario. Let's say I have 3 nodes in one data center, 3 nodes in the other, the link breaks, and then both of my data centers will go down because none of the nodes will be able to form majority, so I need 3 data centers. In Percona Server 5.6, the indoor data center communication can be optimized with group segments. That means that, for example, in case of 9 nodes, the originating node will send the transactions to 8 nodes in parallel, which is, if WAN is involved, it's slow. If we are putting them into separate group segments, the group segments will choose gateway nodes within group segments, and over the WAN, the write set is transmitted only once. And the gateway nodes can change actually transaction by transaction. On the right-hand side, we see a scenario when we have 2 data centers and we only have an arbitrator in the third one. Common caveats of PXE, or why is it different? First, it's InnoDB only. This mechanism we do replication is good for transactional storage engines. If a node fails, the writes are stalled until suspect timeout is reached, which is by default 5 seconds, but reads will continue to go on. Conflicting transactions can be an issue if you write on multiple nodes. If you think back about what we talked about, how replication works and how certification works, if you have lots of conflicts, you have lots of certification failures, and at the time of certification failure on the originating node, the transaction is rolled back. While in regular InnoDB, this is just the lock wait. So a rollback involves I/O, and it's much more of an issue if you have conflicting updates here, which means 2 transactions are updating the same record. And I'm talking about this issue because we know that Nova actually hits this. So if you have a busy Nova database, you might end up doing better if you write only on one node and read on all the others. And long transactions are more painful than in the single node case. If you think about it again, how replication works, if in the queue we have a long-running transactions and the queue is applied in parallel, then all the transactions will wait the long-running one. So always test carefully with your workload, because it's a fundamental change in how replication works. Percona XtraDB cluster is available in latest Ubuntu LTS. It can be installed via Juju Charm, and it's a certified high availability option in Red Hat Enterprise Linux OSP. Thank you for listening, and thanks the sponsors for making this vBrownbag possible.